Hi everyone, my name is Arvin G, and today we will continue the subtrade series with the Forkless upgrades. So we can initiate a Forkless runtime upgrade. One of the defining features of the subtrade blockchain development framework is its support for the Forkless runtime upgrades. Forkless upgrades are a means of enhancing a blockchain runtime in a way that is supported and protected by the capabilities of the blockchain itself. A blockchain's runtime defines the state of the blockchain can hold and also defines the logic for affecting changes to that state. And see this runtime storage. Okay, subtrade make it possible to deploy enhanced runtime capabilities, including the break changes, without the hard fork. Because the definition of the runtime is itself an element in the subtrade chain state, network participants may update this value by the way of the extrinsic specs, specifically the setcode function. Since updates to runtime state are bound by the blockchain's consensus mechanisms and the cryptographic guarantees, network participants can use the blockchain itself to just listly distribute, update, or the extended runtime logic without needing to fork the chain or even release a new blockchain client. So this tutorial will use the subtrade developer hub node template to export two mechanisms for Forkless upgrades of the frame-based runtimes. First, the pseudo untracked wait function from the pseudo palette will be used to perform an upgrade that adds the scheduler palette. Then, the schedule function from the scheduler palette will be used to perform an upgrade that increases the essential minimum balance for the network accounts. If you have problems with the tutorial, you can ask the community at this link. Okay. It's have many parallel. At first you can search it. The Forkless Runtime. Okay. Some problem with the answer. Okay. And now what we will be doing before we even get started, let's lay out what are we going to do over the process of this tutorial. We will use the pseudo call to include the scheduler palette in the live runtime, and we can schedule a runtime upgrade. So we can receive a learning outcomes. After this lesson, we can understand some basic governance features in the subtrade chains and gain experience with how the subtrade chain can upgrade its runtime. And we can learn how to use the scheduler palette in your runtime. Now we can go to the pseudo upgrade. This part of the tutorial will step you through launching the subtrade chain and initiating a simple runtime upgrade using the sudo palette. Now we start the template node. Since Forkless runtime upgrades do not require network participants to restart their blockchain clients, the first step of this tutorial is to start the template node as is. View and start the unmodified template. Okay, I will open my node and check it. Run the node. Okay, I checked and my node is working. So I will start it by Ctrl plus C. Okay. Now we leave the node running and notice that the node will not be restarted as part of this tutorial despite the fact that two runtime upgrades and performed. You will be editing and recompiling the node's runtime code, but do not stop and restart the node to prove yourself that the runtime upgrade is in fact done on the active network, not review or restart one. Now by default, the well-known Alice account is configured as the holder of the sudo palette key in the development config function of the template node's train specifications file. This is the configuration that is used when the node is launched with the dev flag. This means that Alice account will be one used to perform runtime upgrades throughout this tutorial. Runtime upgrade resources accounting. Dispatchable calls in the subtray are always associated with the wait, which is used for the resources accounting. Frames system module bounds intrinsics to block length and block weights limit. The set code function is in the system module is intentionally designed to consume the maximum weight that may fit in a block. The set code function's weight annotation also specifies that extrinsic call is in the operational class of dispatchable function, which identifies it as relating to network operations and impacts the accounting of its resources, such as by exempting it from the transaction byte fee. Use sudo to dispatch. As the name sudo palette implies, it provides capabilities relate to management of a single sudo superuser to sudo is superuser administrator. In frame, the root origin is used to identify the runtime administrator. Some frames feature including ability to upgrade the runtime by way of the setcode function are only accessible to this administrator. The pseudo palette maintains the single storage item, the ID of account that has access to the palette's detachable functions. The pseudo function allows the holder of this account to invoke a detachable as the root origin. For example, the following piece pseudo code demonstrates how this is achieved. Refer to pseudo palette source code to learn more. You can see the new function pseudo with the two parameter origin and com, and you make the sort the site origin to sender, and if it not origin, we have error requires pseudo, and now we can call it. Okay. In order to work around resource accounting within the frame safe words, the pseudo palette provides the pseudo untracked way function, which provides the same capability as the pseudo function, but accepts the additional parameter that is used to specify the possibly zero weight to use for the call. The pseudo untracked weight function is what will be used to invoke runtime upgrade in the section of this tutorial. In next section, the scheduler palette will be used to manage the resources consumed by the setcode function. Here we allow for the block that may take an indefinite time to compute intentionally. This ensures that our runtime upgrade does not fail, no matter how complex the operation is. It could take all the time it needs to succeed or fail. Wow, it's so amazing. So we go to the prepared and upgraded runtime. Now we can add this scheduler palette. Because the template node doesn't come with the schedule palette included in its runtime, the first runtime upgrade performed in this tutorial will add the palette. First, add the scheduler palette as a dependency in the template node's runtime cargo file. Go to the Visual Code. And I go to my node template folder. Node template. Okay. Okay, I will test my runtime cargo. runtime. Go to cargo file. Okay, you need to add the palette schedule. Okay, and next step, you will add the palette schedule STD in the features. STD. Okay. Now you can see the features and Cine here, and add the palette scheduler here. Okay, and you save it. Okay, after save the cargo file, you can go to runtime and RC lib. Okay, runtime. And you can see the parameter types. We can copy this and add the file below the parameter type. Okay. Here, as you can see, can add this here after the parameter type. Parameter of the minimum period. Okay, and now you can go to under and add the import palette schedule function under the parameter type. It's here. And last one, you can go to the construct runtime and add this line, scheduler palette schedule. Okay, go to the runtime, construct runtime here, and add this line. And on the top of the file, you copy this variable and add it in the top of the file. Okay, you can see. Can add it here. And the final step preparing the upgrade frame runtime is to increment its spec version, which is a member of runtime version struct. Go to the lib and add this function, public function. Now you can see we have added a public constant version, but the one you can change is the spec version to the 101 here. Okay, I will modify it. 101 and save. Oh, some information about the version. We have a spec name, the name of runtime train. Example, the Ethereum, the import name, the name of client, such as the Open Ethereum. And we have a authoring version, the authorship version for block authors, and the spec version, the version of the runtime and train, and import version, the version of the client and APIs, a list of supported APIs, and we have a transaction version, the version of dispatchable function interface. In order to operate the runtime, it's required to increase the spec version, refer to implementation of the frame's system module, and particular the concept code function to see how this requirement and others are informed by runtime logic. Okay, we will view it by this code. That we save the file, okay, and build that. Okay, my node building with the node arrow, and we go to operate runtime. Okay, we go to use this link to open the Polkadot.js UI and automatically configure the UI to connect the local node. Okay, I will test this by running the node with the run dev. Okay, after you running the node, we go to the Polkadot UI. Okay, I go to the app UI. Okay, next step, I will go to the sudo untracked wait, sudo unchecked wait, and upload the template runtime compact worm. System set code. Okay, this is my the target release. Target release and W build. And not template runtime and not template runtime compact worm is here. Okay, I will upload this file and then I submit the transaction. Sign. Okay. And now after the transaction has been included the block, the version number in the upper left hand corner Forkless app UI runtime version is now in 101. You can see it's a 101. Okay, in the next step we will go to the schedule and upgrade. Now that the node template has been upgraded to include the schedule palette, with the schedule function can be used to perform the next runtime upgrade. In the previous part, the pseudo untracked wait function was used to override the wait associated with the setCode function. In this section, the runtime upgrade will be scheduled so that it can be processed as the only extrinsic in a block. Now we have a prepare an upgraded runtime. This upgrade is more straightforward than the previous one and only requires updating a single value in the runtime src lib, aside from the runtime spec version. Now we can go to the lib src and modify the spec version to the 102. Now spec version is 101 and we will modify it to 102 and save it. Okay, and we also upgrade the value of the extensional deposit. Here you can go to the parameter types. Extensional deposit. And go to find that. Yeah, this value, and you will modify this to 100 inside 128. Okay, save it. So this change increases the value of balance extensional deposit, the minimum balance needed to keep account alive from the point of view of the balances palette. Now we can build the upgrade runtime. Can start the node build. I hope that's no make an error. Okay, wait for a minute. Okay, my node build with no error, and now we go to the Popular.js arc. And after that, we will run the node here. Okay, and I will go to the Popular.js. Okay, it's waiting for the node running. Okay, and after I start my node, we will go to check some information. So now that we go to the developer and go to the scheduler, and go to the function schedule when maybe periodic. Okay, and we set up the block. When the block number. Okay, now we in the block 13, and I will go to make an event in the block 50. Okay. Now we submit it. Okay, the event is making, and we go to the explore. It's now in the 19 block, and we wait till the 50 block. Okay, after the 50 block, we have a new event. It is scheduled departure, and it's in the block 50, and result is okay. Okay, and something we can check if the version of the node template is 102. Yeah, it's all about today's video. Thank you for listening, and see you in the next time. Goodbye.